Dilution is the addition of water to a concentrated solution. We use the equation M1V1 equals M2V2. So molarity times volume equals molarity times volume. Your volumes can be both in milliliters or both in liters, but they do need to be in the same unit. So the units will cross out. And the moles of solute before dilution will equal the moles of solute after dilution because we're not adding more of the dissolved substance, we're just adding water to it. So if you go to the freezer aisle and you look at the juices in the freezers, they have concentrated juices. Those are very, very concentrated. They have lots of juice and very little water. So when you go home, you dilute it by adding water. You're not adding more juice to it, but you're spreading those juice particles out so they're diluted. So let's see one of these example problems. It says, what volume of 14 molar HCl must be used to make 100 milliliters of a 6 molar solution? So what volume, so that's V1, of a 14, so that's going to be my M1. Notice it says of 14 molarity. It doesn't matter if I say that's V1 and M1 or V2 and M2. What does matter is they have to both be 1s or they both have to be 2s because they go together. And notice these two, it says 100 milliliters of a 6 molarity. So those two go together. So this is V2 and this is M2. Notice you have 2 volumes and 2 molarities. So that's how I know I'm going to use the dilution equation and not the molarity equation that we talked about previously. In this problem, I'm solving for V1. So step 1 is write your equation. Step 2 is rearrange that equation. So V1 is equal to M2, V2 over M1. Because I would divide by M1, divide by M1. Make sure that you show this rearranged equation on your paper. If you are not showing the rearranged equation, you will not be getting full credit. So now we just plug those values in. So I have my M2, which was 6 molarity. Next is my V2, so 100 milliliters. Making sure that I put my units in there so I can cross them out and make sure that everything is crossing out. And M1 should be on the bottom. You can place it anywhere on the bottom. I'm going to place it under the molarity so I can easily see molarities cancel and I'm left with milliliters. Multiplying and dividing, I get 42.86. But I need 2 significant figures, so that's 43 milliliters. That's 43 milliliters of 14 molar HCl. Because we were finding the volume of 14 molarity HCl. The second part of this problem says, well, how would I make this solution? This is the one people usually struggle on because they don't know what they're doing. They're just plugging numbers in. So make sure that you're aware how to solve this problem because you will see it on tests and quizzes. So I'm trying to make 100 milliliters of solution. So my final volume, I need to be 100 milliliters. Well, my more concentrated one, I'm going to put in 14 molarity HCl. I'm going to use 43 milliliters of it. So the only way I can get to 100 milliliters is if the rest of that is water. Because the definition of dilution was you were going to add water to a concentrated solution to dilute it. So to find how much water, all I need to do is subtract. 100 minus 43 is going to tell me how much water I've used, which is 57 milliliters. Water is never in the dilution equation. You always have to subtract or add to get your volume of water. So that tells me how much water I need to add, but that doesn't tell me how I would make the solution. That since this is an acid from our safety rules, we should always add the acid to water. So in a sentence, I would add 43 milliliters of 14 molar HCl to 57 milliliters of water. And again, I added the acid to the water because safety-wise, we add acid to water so it doesn't splash or create too much heat. Notice the two volumes add up to the final volume that I needed. All right, let's look at this one together. It says how many grams of NaCl would I need to make this volume of a solution and this molarity of a solution. So I only have one molarity and one volume. So I'm going to be using the molarity equation. I'm looking for grams. Remember, anytime we are solving for the molarity equation, we need to write out what molarity means. So a 4 molarity solution means I have 4 moles of NaCl for every 1 liter. Make sure that if it's a molarity problem and I give you molarity, you have that written on your paper. It's going to make your solving much easier. So I can't start with my conversion factor. So remember from the previous lesson, we're going to start with our 50 milliliters. Go ahead and pause the video and convert your 50 milliliters of sodium chloride to grams of sodium chloride. Restart when you have an answer. So to use my conversion factor, I'm going to have to convert my milliliters to liters. So you should have written 1,000 milliliters is 1 liter. Now I can use my conversion. I need liters on the bottom, so they'll cancel. And I'm converting to moles. Again, using that conversion factor. 1 liter is 4 moles of sodium chloride. But I don't want moles, I want grams. So 1 mole is equal to so many grams. I get those grams from the periodic table, and that's 58.44. So multiplying and dividing, you should get 11.69, which is 12 grams in 2 sig figs. And that's 12 grams of sodium chloride. Part B says how many milliliters of water would I need to add to have a molarity of 2.5? Well, I have B1, and I have M1, and this is going to be M2, so I can use M1V1 equals M2V2 now. And I'm solving for my B2, because that's the only one I don't know. So your rearranged equation is M1 times V1 over M2. Looking up, I have my 4 molarity times my 50 milliliters, and that's over my 2.5 molarity. Molarities cancel, and I'm left with milliliters. Multiplying and dividing, I get 80 milliliters. But that's 80 milliliters of 2.5 molarity sodium chloride. This question is asking how many milliliters of water. Remember that we said that the dilution equation does not have water in it. We're adding water to dilute it. So to find how much water we added, we always subtract our two volumes. So we started with 50, now we have 80. So 80 minus 50 means we must have added 30 milliliters of water. So read carefully, and if it says you added so much water or how much water did you add, you're going to have to either add or subtract depending on the problem. I'm going to pause the video and try this one on your own. Restart when you get an answer. So you should have gotten B. If you didn't get B or you're unsure how to show your work, make sure that you pause the video when the answers come up in just a second. And so this is how we got 0.12 molarity H2SO4. If it had said how much water do we need to add, we added 1,000 minus 10, or 990 milliliters of water was added to the 12 molarity H2SO4 to dilute it to 0.12 molarity. But this step wasn't needed in this problem. But if you were asked water, that's how we would solve it. This last problem is a little bit different because I have HCl and I have NaOH. HCl, from our previous units, you should know is an acid. And from our reactions unit, you should know NaOH is a base. So acids can neutralize bases. And as long as it's a 1-to-1 ratio, we can still use the equation M1 times V1 equals M2 times V2. We'll put all of our acid information on one side and all of our base information on the other side. So it's very similar to what we were doing before. The only difference is now we have an acid on one side and we have a base on the other. So I'm going to pause the video and find out how much HCl we would need to neutralize that amount of base. Restart when you have your answer. So if you got C, 87.5, then you are correct. And you can go ahead and stop the video. If you didn't, then wait for the answers to appear and pause it and see what you did wrong. So this was V1, this is M1, M2, and we're looking for V2. Or you could have said that was V1, M1, V2, and M2. So again, the M1s and M2s don't matter as long as we group what should go together.